Today's objective will be to solve systems of linear equations algebraically using the substitution method. Our mathematical practices are number 2, reason abstractly and quantitatively, and number 6, attend to precision. Algebraic methods are used to find exact solutions of systems of equations. One method we are going to look at is called the substitution method. Okay, let's take a look at an example using the substitution method to solve our system of equations. Read your directions, and again, if it specifies which method to use, please do so. This one says solve by substitution. So here's my system of equations, and I have my variables of y in the green color, and then I have the variable of x in a pink color. That's so we can see the difference. So substitution, if both equations are solved for y, then y is equal to y, so I can substitute in the first equation this negative 2x plus 1. So by substituting that in, y is now going to be replaced with this negative 2x plus 11. That's going to equal this 3x minus 4 that was already given. Okay, just a quick recap. Our variables were both y, they were both isolated, so that way I could substitute in this negative 2x plus 11 up here in this first equation. You could do the same, substituting in this first equation into the second equation, makes me no difference. So now we've got one equation, one unknown. Let's solve this equation for x. So let's add 2x to both sides. 2 minus 2 is 0. That leaves me 11. 3x plus 2x. Add those together, give me 5x, and bring my minus 4 down. Because I brought my x's to the right-hand side of the equals, I'm going to take my constant to the left-hand side. So let's add 4. So 11 plus 4 is 15 equals 5x. Last step is to divide both sides by 5, leaving me an x value of 3. Now, we must have a coordinate as our solution if there's a solution to this system. So far, 3 is my x value. In order to find my y value, I'm going to take what I just found, x is equal to 3, and substitute that back into either one of these equations for my original problem, or my original system. Again, it makes no difference. Whichever one looks easier to you is fine to use. I'm simply just going to sub that into the first equation. So y equals 3, x is now 3. So 3 times 3 minus 4. I'll do my calculation. So 3 times 3 is 9. And 9 minus 4 is 5. Now that I have my x coordinate and my y coordinate, I can write that in my final answer. Three, 5. Now I would like for you to stop the video and practice this problem in your notes. Example number 2. Solve the system of equations using the substitution method. In the previous example, both equations already were solved for y, so we could just substitute those in and solve. This system is a little different. We have to do our own solving for y. So look at your equations and pick what looks like the easiest equation to solve for. To me, that's going to be this first equation, because I have y kind of by itself instead of having a constant with that y. This just means it's going to be a little bit simpler to solve. You can solve either one, doesn't matter. So if I want to solve this equation for y, again, subtract 4x from both sides, negative y is left over, equals negative 4x plus 1. To get rid of this negative 1y, we're going to divide everything by negative 1, leaving me with an equation of y equals 4x minus 1. All right. So that's this y equation. Once I have y solved for itself, I can substitute that into my other equation. So, anywhere in this second equation I see a y, I'm going to replace it with 4x minus 1. So here's what we get. 5x plus 2. Now it's y, but we're going to replace the y with the 4x minus 1. And then equals 24. Please use parentheses when you substitute in an expression into your equation. This will just keep things clean and moving right along. So let's solve this equation. Now I have one equation and one unknown. Let's solve this for x. First thing I want to do is distribute this 2 on the outside of the parentheses. So 5x plus 8x minus 2 equals 24. I'm going to combine any like terms that I have so I can take and combine those together. And I get 13x minus 2 equals 24. I'm going to continue to solve this for x. Okay, so when I do that, I get an answer of x equals 2. Now that I have my x, I can take and plug that back into either one of my original equations to find my y value. So let's do that. Again, it doesn't matter which one you choose. I'm going to choose this top one. So 4x minus y equals 1. I'm going to plug in or substitute in x is 2. So 4 times 2 minus y equals 1. I'm going to solve this thing for y. Okay, once I've solved for y, once I've solved for x, I can then write my answer as a coordinate. So 2, 7 is my final answer or solution to this system of equations. All right, the next example says, again, solve the system of equations using the substitution method. So on the last example, it was easier to solve an equation for y because we had one equation that had a y with no coefficient or number in front of the variable. So I'm going to look at these two equations that are given in my original problem or my original system. What I notice is that my x does not have a coefficient. My y has a coefficient of 5, my 3 has a coefficient of, or my x has a coefficient of 3, and my y has a coefficient of negative 2. It's going to be easier to solve this first equation for x. So let's do so. If I want to solve this for x, I just have to move the 5y to the other side. So I can subtract 5y from both sides. And I get a new equation of x equals 3 minus 5y. It's okay to put your variable second. You don't have to, but you can if you want. So now that we have our x equals 3 minus 5y, I'm going to substitute this in. 3y, or 3 minus 5y is going to get substituted into that second equation for x. Because we solve for x and this variable is x, we replace that. So let's do it. 3 times x is now 3 minus 5y. And then minus 2y equals negative 8. I just copy the rest of my original equation after I've substituted in. So let's solve this equation. All right, after I've solved this equation, my y comes out to 1. So once I have my y is equal to 1 value, I can go back and substitute it into either one of the original equations and calculate my x value. Again, it doesn't matter which one you choose, just choose one that looks easiest for you. I'm going to pick this top equation. Okay, so I'm going to substitute y and 1. So I get x plus 5 times y, but y is 1, equals 3. Let me solve this equation for x. So I get a value of x equals negative 2. Once I find my x value and my y value, we can write our answer in a coordinate pair. So my answer would be negative 2, comma, 1. Now it's time to stop the video and practice number 2 in your notes.